Hello and welcome back. In this video, we're going to be talking about how we use our skills with graphing absolute value functions to solve absolute value equations graphically. Now, we've learned how to do this method algebraically, but we'll talk a little bit about how we can use this as well to help us to do this graphically. Now, this is a skill that's going to become important for other concepts as well, okay? And it's always handy to be able to understand the behavior of our graphs, okay? So when we're solving absolute value equations graphically, we're essentially performing simultaneous equations, okay, for both the left-hand side and the right-hand side, okay? Now, what we're doing is we're going to essentially be creating a function out of y equals 2x minus 1, which you can see here, and turning this into an equation called y equals 3, and that's just a horizontal line at y equals 3. And we're just going to find their points of intersection. Now, to be able to do this graphically, what we need to be able to do is to be able to graph each function, okay? Now, y equals 3 is fairly easy. We'll do that last. So what we might do is we might focus on graphing this left-hand side function here, okay? All right, so step one, as always, when we're graphing absolute value functions, it's handy to understand the behavior. So we know because this is a negative one, it's going to shift right, not 1 units, but a half unit. You're going to see that when I go to find the x-intercepts in a moment. But let's find the y-intercept first, okay? So to find our y-int, okay, we let x equal 0. Therefore, we have y is equal to the absolute value of 2 times 0 minus 1, okay, which will give us the absolute value of minus 1. So our y-int at the end of the day, when we take the absolute value of minus 1, is just simply 1. Okay, now we might just label that in there for us. Okay, so we have that occurring here at y equals 1. Okay, now we're going to find our x-intercept. So to find our x-intercept, okay, we now let y equal 0. Okay, so therefore we now have this equation, 2x minus 1 is equal to 0. Okay, I'm going to again do this via cases. Okay, all right, we check case 1. Okay, I know that I'm only going to be expecting one solution, okay, but I'm going to check both cases anyway just to show you because this hasn't been moved up or down, it's only been moved left or right. All right, so case 1, we solve for 2x minus 1 is equal to 0. Add 1 to the other side, we have 2x is equal to 1. Divide by 2, we have x is equal to a half. Remember how I mentioned to you before it hadn't been moved a full 1 unit across, it had only been moved a half, that is y, okay? Then case 2, okay, we do the exact same behavior, but we take the negative case of the absolute value. All right, now this is going to behave the exact same way. We're going to multiply both sides by a negative to then receive the equation 2x minus 1 is equal to 0. And we know the answer to this equation because we've just went and found it. It's going to be the exact same thing. All right, so our only x-intercept is going to be equal to a half. So let's now add that onto our graph here. All right, so it's going to occur right there at x equals half, and we also have our y-intercept occurring at 1. Okay, so let's have a little bit of a practice and have a little bit of a play with everything. We'll do our final step, which is to recognize whether it's positive or negative, and we know that it's a positive graph because when we go back up to our equation that we have, there is only a positive out the front of it. Okay, so now it's just a matter of graphing our equation. So we know that it starts here at a half. I'm going to do the left branch this time. Okay, so you can see what's happening. All right, and go this direction. All right, now I'm going to draw a little bit longer here just so you can see what's going to happen very, very shortly. All right, now what I like to do is that technique that I was telling you before about imagining what would happen if our right branch would continue on below the axis, like down here. All right, now if we were to graph y equals 2x minus 1, this weird behavior here, we know the y-intercept would happen at -1 down here. Now I'm just going to put that there just so you can sort of see what's happening. Now, the reason why I do that is because it then becomes very, very easy for me to then draw the graph following the behavior from this one here, okay? So if I just draw this graph going through, okay? As long as I keep everything lined up, it is very easy for me to draw, all right? Now, what I would suggest that you would do is I would suggest that you would sit there and you would rub out this line. That's why it's very handy to draw to draw your lines with a pencil, okay? And it's just a bit of a handy little trick for you to be able to graph your absolute value function neatly, okay? Alternatively, you could just recognize that the gradient is m is equal to 2 over 1, and then from your point of a half, you're just going across 1, shifting up 2 each and every time, which is where these values come from. Now, the other thing that we need to now do, once we've drawn our absolute value graph, which is there, okay, so we'll label it, this is y equals the absolute value of 2x minus 1, is we now have to draw y equals 3. Now that's relatively simple, okay? We just go up to where y equals 3, and we just draw a horizontal line, okay? Let me try that again. My iPad didn't register it, okay? We just draw a horizontal line, just enough so we can see where it's going to cross our absolute value graph. So here's our equation y equals 3. Now immediately this becomes very, very simple to see, all right, what the solution will be to our equation. You'll notice here that we cross here at x equals -1 and here at x equals 2. We only care about the x value because we are only trying to solve this equation here. So the values that solve this equation are x equals -1 and x equals +2. So that is how we solve it simultaneously. So we end up with x equals -1 and +2 being our values. Simply all we do is graph both equations, and then what we do from there is we find their point of intersection and use the x values, okay? And that's all that we need to do, okay? Thank you. I hope you found this helpful.